So following on from the previous video, we've seen that whenever you have a function, let's say 10 to the power of x here, well, whenever you have a function, you can always create an inverse version of that function by reflecting it along the y equals x line here. So in fact, log of x is the inverse of 10 to the power of x. And then if you have a function, any function, let's say some constant to the power of x here. Suppose you're given this function here. You can always create an inverse version of this by reflecting it along the diagonal line here, along the y equals x line here. Okay, so in fact, the natural log of x is the inverse version of this thing here. Okay, so in the past when you're asked to solve this here, so we've done many exercises on this. 6 to the power of what will give us 723, whatever over here. So in the past, if you're given this problem here, you would log equally to both sides. So when you log equally, so whenever you use this button here on your calculator, it's always defaulted to a base 10. So anyway, in the past, when given this here and you're asked to solve x here, you would log both sides, and then that will give you this times this equals this thing here. You would then divide both sides by log 6. So the index here is equal to this. Now what I'm trying to show you in this video is that this thing here, this log, whenever you make this log thing here, when you log both sides, it will still work even if you use natural log. So you can use natural log. When you're here, you can actually use natural log both sides rather than having to log this. So you have two ways of doing it. So and the reason why that works is because of this. Is because of this this here. In the past, we've said that whenever you've got x to the power of n, you can log base a equally to both sides, and then the n goes down here. You see, because of this statement here, log base a. Well, log base a could be anything. It could be log base 10, or you can use 2, or you can use log base e, and it will still work. So hang on. So when you have something like this here, hang on. Suppose you have b to the power of x equals c, and your job is to work out b to the power of what will give us c. So in the past, you would log both sides, but then your next move here, given this stage here, you would log both sides. You would log both sides, and then the x will go down here. You see, when you log both sides to the base a here, the point here is that when you log base a, it doesn't matter what base it is, it will still work. So starting from here, if you log base a, it will give you this thing here. And then if you want to get x on its own, then you would divide both sides by log base a of b. So x here equals this thing here. Looking at this here, because it's log, because you've got this theorem here that says you can log base anything, and then the n will go down here. Well, anything could be to the base 10, it could be to the base 2, it could be to the base 5, it could also be the base e. So when you're given this thing here, to solve this, you could instead of using log base 10, you could actually use this button on your calculator, ln, natural log. You could actually use the natural log button on your calculator. So given this here, you could solve it by doing this. Hang on. B to the power of x equals c. You could actually natural log both sides, okay, equals the natural log of c, and then the index will equal natural log of c divided by natural log of b. So you can either, well, this a here could be, the base here could be anything. So it will work with 2, 3, 5, or it would even work with e. And don't forget, in the case of e here, hang on. So when you have 10 to the power of x here, the inverse has a special name. It's called log. Now, in the case of e to the power of x here, the inverse has a special name because it's quite special. So we give it a name, the natural log of x. So really the log of x is actually the inverse of this thing here. So the normal log of x is the inverse of 10 to the power of x. Now the natural log of x here is the inverse of e to the power of x. So let me give you an example here. Hang on. Let me give you an example here. So let's say you're asked to solve this. 8 to the power of what will give us 273. Now the normal method, the log method, this here is the natural log method. Okay, so the normal log method here is that you would start here, log both sides. So that would, well, log both sides is really, your calculator would default it to log base 10. Okay, so when you press the log button on your calculator, you're actually performing log base 10. So this is this is me showing you that you can solve this by using the ln button on your calculator, or you can use the log button on your calculator. So the log button, so hang on, so if you're here, so you're trying to solve x here, so you would log both sides. That would mean you going down this direction here. So log both sides, that would then give you this here, and then x equals this thing divided by this thing. Now if you get your calculator, you would get this log 273 will give you this thing here, log 8 will give you this thing here, and then divide this, and then x will give you this. Now going back to the start, now let's take the ln root, here. Now you've got to use this button on your calculator. So given this here, ln both sides, that will then take you to this. Okay, so now natural log this, and then natural log this. So that will then give you this here divided by this, and that, you see the two methods. This thing here will then give you this thing here. You see the two methods the two methods will give you the same answer. So to solve this here, you can either use the log button, or you can use the ln button on your calculator. Okay.